Okay, we started with a non-homogeneous equation and an initial condition. We found the fundamental matrix. We call it the psi matrix. We assumed a solution to the equation that was of the form psi of t times u of t, where u is some column vector. We took the derivative u prime of t using the product rule. Well, we went through all the steps and the preceding couple of clips, and we obtained u prime of t equals psi inverse g of t, where g of t is this function. Psi inverse is the inverse of our fundamental matrix. Psi inverse is equal to this, giving us an equation for u prime of t. U prime of t is psi inverse times our G matrix, and that comes out as you see here. Negative 1/5 t e to the negative t plus 1/5, 2/5 t e to the negative 6t plus 3/5 e to the negative 5t. Now we need to integrate this u prime of t. So u of t is the integral. The integral goes from t naught. Remember, the initial condition was for y of 0 equal 1, 1, the 1, 1 vector. So we integrate from 0 to t of u prime of t plus a u0 vector. Remember that the u0 vector is the psi inverse vector evaluated at 0 multiplied by the y0 vector. Now there's a reason for that, because when we go back to our assumed solution, which is of the form psi times u of t, we'll be multiplying psi by the u naught vector, and we should get the y naught vector, so that u naught should be the inverse psi times y naught. And doing the inverse psi times the y naught vector, we just do the inverse psi evaluated at 0 times the 1, 1 vector. Psi inverse of 0 is negative 1/5, 1/5, 2/5, 3/5, just the constant terms that we have here. And multiplying that by 1, 1, and we get 1, 0. So the u naught vector is 0, 1. Now there's nothing difficult about what follows. We just do straightforward integrations, but the constants end up being pretty non-intuitive. Well, they're not non-intuitive, they're just fractions, but the fractions get pretty big. That's because I just randomly chose an example. I didn't bother working it through, and I kind of wish I'd have worked one through, but on the other hand, this is the way they often come out. So let's go ahead and just take a look at what we get.